week because we have a few things going on. And this being the week before Thanksgiving, kind of want to give you a heads up on some of the assessments we're going to be having and where everything's going to fall. So, first thing is that if I did not stamp you on Friday for your Chapter 10 homework Part 2, then I'm going to be doing that today, okay? After we do a few little kind of debriefing and pulling all these concepts together, you're going to be doing this review or this warm-up for your Chapter 10 quiz, which is going to happen tomorrow. Now, you also picked up a Chapter 7 through 10 review. It is not due until Wednesday, so let's talk about this for a second. First of all, it has graphs that copied very dark, copied darkly, or whatever, so you can't see them very well. And that's why I have markers up here, just so that if you want to use a marker so that you can see the points better, since it's copied off so dark, then you can use those. All right. Hey, if you happen to be one of those people gone to the field trip, the medieval times, I'm not sure when you're getting back on Friday. I think you guys get back around 2:30. Okay. So you should be back for this class. However, in the event that you are not, here's the deal. You know how on reviews I give you quite a bit of stamps on your reviews? Well, you have to come in here and have me stamp you on Wednesday, because Wednesday after school I'm going to post the answer key, and I'm going to post the going over video for those people who were gone during class. So you cannot come in Thursday and expect to get your stamps, because the answers are going to be out there in the afternoon. Alright, so you need to make a special effort to get in here if you want to get those stamps done. Alright, so, okay, so that's the deal in the review. We are quizzing tomorrow, okay, going over some things today on that. That test is then Thursday. So for those of you going on Wednesday, you'll want to go over that stuff so that when you come back Thursday, you test. The quiz that you have tomorrow, you are going to be turning in these items. I stamped you Friday for these two. I'm stamping you today for this one, and then tomorrow I will stamp you for this warm-up. Okay, so that's all the business stuff. Now, let's talk about the differences between the exponential and the power model. So let's kind of summarize those and get all that straight. I've recently learned about those steps. Talk to me about exponential model. What do you know about exponential model? What does it do? What does it use? How's it go? Very good, very good. It is a transformation, and it has the regular x and the log of the y. Okay? When do you end up wanting to do an exponential transformation? Okay, what's the regular thing? The linear model. Very good. Okay, so we would use this if there is a pattern in the residual plot of the linear model. And there, if you would like to write this on the back of the warm-up that you picked up, there's a blank page back there. You don't have to, but if you're a person who likes to kind of write this stuff down and keep it straight, there's a blank page on the back of the warm-up. Okay. All right, good. Okay, how about this? What is the parent function? What format, when you unlog the problem, what does it end up in? What form does it end up in? Predicted y is something like that, but not quite that. Yes. You know that up here, remember the variable is in the exponent because it's an exponential equation, okay? Alright, so that's how you can keep that one straight. Good. Okay, then let's now compare that to our power model. What transformation do we go through for our power model? Good. We log the x and we log the y. And when do we make a decision to do that, go through that transformation? Good, 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 good. So what happens is there is a pattern in the residual plot of the exponential model. Good, good, good. And so in that format of its parent function is going to be our predicted y equals, good, a. X is your base in this case with an exponent b. All right, we're going to actually do some computation of this to refresh your memory on that shortly. But here's the deal. The big thing is, why did we just spend 3 days last week talking about transforming stuff? Why did we do that? When we got things transformed, when they became a power model or whatever, for example, in this case, 0.977 times x to the 3.02. What model is that? That is a power model, and how do you know? Because the x is the base. Okay, so here I have this, and it's going to fit this data right here. So my question is, these points, what data is that? Is that original? Is that logs? Is that residual stuff? What? It is the original. Very good. The whole purpose of finding this weird equation, which we found to be, in this case, this power model equation, is so that I could find the equation that fit the original data. That's the ultimate goal, is find the equation that fits the original data. Now we had to go through the process of smashing it and making it linear, condensing it, making it linear to find the linear equation, and then unlogging it back up. Okay? But the goal was to get it to fit the original data. So, why? What's the whole purpose of finding the equation that fits the original data? Okay, we are going to talk about extrapolating, and you saw that word there. Something else though. Why? Why do I want this picture? Why do I want the function that matches those points? Predictions. Correct. So that I can make an accurate prediction, because I can say what's in that general vicinity. So good. The reason is because we want to predict business models, medical trends, all these different, financial statements, everything I can think of that you would be using these functions for, economic trends. So it's so that you can make a prediction. Very good. Okay? Ultimately, we want to be able to predict. Be the first one. Figure it out before everybody else. Predict what you can do. Now, we have not addressed this word extrapolate. It's a really important word, and I think now we're into context to be able to talk about that. Okay? Predicting is our goal. First, tell me, what do you know about this word extrapolate? If you just thought of it in regular context, what would you say extrapolate means? Okay, good. Okay, good. Very good. To predict outside of the data that you have been given. Perfect. That is the definition of that exactly. Extrapolation is predicting outside the data that's given. So here in this picture, this is from last week. I think we were talking about the length of some frogs or fish, or I don't know what it was, and we were attempting to predict the weight of those items. Okay, and so we could tell that within our data, it followed this pattern. All right. Now let me give you an inside scoop on the window. This went from 0. This number here is 6. So let's talk about going outside this data, okay? Let's talk about extrapolating. So if I was to ask you, what is the weight of this fish or frog or whatever that is 10 inches long, you would then do what? Plug it into that function that you got. Plug 10 in to this function. Okay, so guess what? You're going to get something that is like crazy high up here. It's so high, I mean, I don't even know if I can map that. It's going to be, you know, plotting up here. Something way, 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 way up there. Because it was a power model, and it went way high on that. So my question is, do you think that that's an accurate prediction? Do you think that you could count on this data continuing this extreme growth? I don't think you can count on that for sure. You can't guarantee. See, you cannot guarantee that the pattern, that is happening right now within the data is the pattern that's going to continue to happen. That's the problem with extrapolating. You cannot guarantee that that is going to continue to happen. All right, because you know what might happen? If this is the length and the weight, it might then start leveling out, you know, and then just have some slight increase. All right, I could see that being more what might happen with the length, and this would be the predicted weight, and that would be closer to the actual than probably this way up here. So extrapolation, which is predicting outside of the data given, is bad. It is bad because you cannot count on this function continuing to occur. It could change direction and have a different trend. Okay. So, I want to connect that back to one item that we've talked about. Do you remember when we talk about the y-intercept frequently does not make sense? That is because of extrapolation. So, for example, when we had that problem about the age of teenage mothers in, I can't remember his months or years, and I think it was years, and the weight of their newborn baby, and it was in grams, so it's kind of something we're unfamiliar with. I remember that we ended up having a y-intercept way down here at negative 1,166. And I remember that when people got that, they were kind of going, whoa, what the heck's going on with that? And it was because we had a very wicked and very unusual, unsettling y-intercept. So, what happened? What is the meaning of this y-intercept in context of this problem? When, what? When the mom is 0 years old, she will have a baby that weighs negative 1166 grams. And we said that is not happening. Here is why that's so messed up. Because it is extrapolation. See, the y-intercept is frequently extrapolation. It's far outside the data. In fact, the data probably is not going to go past 10-year-olds. I mean, at the very, very earliest. I can't imagine that being any sooner, okay? So, is 11, whatever is the youngest. I don't know. So, what? Okay, but that's just like in her experience. I don't know what the Guinness Book of World Records saying. Okay, but the point is, no, don't Google that right now. Okay, hey, but the point is that there is not going to be any data in this area because it's just physically not possible. Okay, so it's not going to happen. So therefore, the y-intercept is extrapolation. Extrapolation is bad. Okay, so in summary, we got this exponential, we got this power, we've talked about why we make those transformations, what to do with those transformations, and to watch out for extrapolation. Now, let's go ahead and practice that right here. So pull out your warm-up. Let's do these top two problems, okay? the parent function that best fits the original data, and then you're going to transform the equation back into the appropriate model by unlogging that y. So let's move it back into the equation that fits the original data. Okay, so look at this first equation. Based on its form, which one of our parent functions do you think it should unlog back into? Okay, good. Exponential. Why did you choose exponential? Regular x's and the log of y. Very good. So therefore, this is going to go back into an exponential equation. And the parent function for that form is a times b to the x. Very good. So let's go ahead and work that. We're going to take our y-intercept and set log a equal to that y-intercept. So therefore, 10 to the 1.3 is the a value. And so a's value is 19.95. All right, very good. Okay, so then how about this number in front of the x? Oh, by the way, here we go. Sorry. Okay, by the way, I was going to tell you that if you take a look at this entire piece, this entire component here, one of these items gets unlogged. Whichever one does not get unlogged is the item that becomes the exponent. So in this case, x does not need to be unlogged. See, and it is the one that then is becoming the exponent. So the b value is the one that has to become unlogged. So then that's why we are saying log b equals negative, we do account for that negative, 0.256. So 10 to the negative 0.256 is 0.555. All right. So my answer here for the transformed equation, predicted y equals a times b to the x. See, the item that did not need to be unlogged is the one that became the exponent. Okay, second one we'll do together. Here we go. Looking at it, what parent function are we going to be unlogging this to? The power model, very good, because I have log x's and log y's. So the parent function is going to be a x to the b. So you can see b is the one that is not going to get changed when I unlog this. So here, let me take care of my log and my a's. So 10 to the 0.985 equals a. A's value is, I believe, 9.66. All right, now tell me about this thing right here. When I unlog this, which one gets unlogged? The log of x gets unlogged, and that's going to be turning it. See, the one that gets unlogged is the base, and the one that does not get affected by the log, that one is the exponent. So therefore, b is 2.5. Do you see that? b is not unlogged here because the x was unlogged. So, in summary, in this equation, predicted y equals a x to the b to the... Okay, so you're going to then practice that computation and make sure you feel good about those different forms on numbers 3 through 8. Okay? Now, with this warm-up, starting at number 9, 10, and 11, those are multiple choice questions. And let me tell you something. 9, 10, and 11 are the way that these kinds of problems get assessed on the AP exam. Okay? They take all these little different components that I have taught you and apply them in a new and different way. Okay? These are the ones, this is the ultimate goal, for you to understand these problems like 9, 10, and 11. All right, and then the last one that you have is to do another one of those tables. Okay, dokie, so that's it. I want you to work on this for the rest of the class, and then tomorrow we'll be having the quiz, and those are the 4 things that you'll be turning in with it. Okay, any questions on that? All right.